All right, there are two pages in between 4.1 and 4.3 that I'm just going to go over a couple examples, and then you can um, do some of the work and check your answer. But for instance, the Pythagorean theorem, remember, is a squared plus b squared, so equals c squared. So the hypotenuse is what we typically call c, and then these are called legs because they're the sides that touch the right angle. And so in an example like number 1, I can take 9 squared plus 40 squared and say that's equal to x squared. And so x would be the square root of whatever that is. So let's go over to the calculator. And I can take 9 squared plus my 40 squared, and that's 1681. So let's just see, is 1681. So if I take the square root of 1681, what do I get? I get a 41. So I can finish the problem. The square root of 1681 is 41 for the missing side. So I would go ahead and try 2, 3, and 4. See if you can get those answers, and then I'm going to put the answers up there and we'll just talk about them quick. So pause the video now, do 2, 3, and 4. Okay, so when you have the hypotenuse and a leg, you see the equation here. A lot of times I will just go to hypotenuse squared minus the leg squared, which is 576, and then you square root both sides and you get 24. So hopefully you got 24. Here you know the two sides. That turns out to be 61, and when you take the square root of 61, the decimal is not quite 8, but we'd rather you write the square root of 61. And then on this one, if you do 12 squared is 144, minus 81, you get 63. However, 63 can be broken into square root of 9 and the square root of 7. Square root of 9 is 3. Leave the square root of 7 alone. So this is the best answer. All right, then we need to talk a little bit about some of the SOHCAHTOA stuff. And they don't have the right angle drawn in here, but we're going to put that in. SOHCAHTOA only with right triangles. So the different trig functions. So if I'm trying to find the side, I know this angle. This would be considered the opposite side, and this would be considered the hypotenuse. So that would be sine. So I'm going to do the sine of 50 is equal to x over 5. And to solve that, I just multiply both sides by 5. And my x will be approximately, so we go over to the calculator. One of the things we want to make sure is that our calculator is in degree mode. So go down to degrees, hit enter, because we're dealing with 50 degrees. So we're going to just type in 5 times the sine of 50. So if I do 5 times sine 50 degrees, my calculator's in degrees, so it knows it's that, I'm getting 3.83. So x is equal to 3.83. So what I'd like you to do is label these triangles, try to figure out what trig function you're going to use, and see if you can solve for the x of each problem. So you're going to come back and look at the answers. Pause the video now. So you can see on this one, if I'm using 75, this would be the adjacent next to it. Some students confuse this as the adjacent, but that's across from the 90, so that's the hypotenuse. So that would set up a cosine of 75 as adjacent over hypotenuse. Now, when x is on the bottom, you have to multiply by x first on both sides, and you'll get an equation right here. And then to get rid of it, you divide by cosine. So if you do that, you should get 42.5. Here's my angle. I know the opposite, and I'm looking for the adjacent. Again, x is on the bottom. So you have to multiply by x on both sides, divide the tangent back, and you get 39.6. Now the last one, 66, opposite over adjacent. When the x is on top, all you have to do is multiply by the 8, and 8 times the tangent of 66 leaves you with 17.97. So hopefully you got those three right. Okay, so on these next examples, these are special right triangles. So 45, 45, 90, and the 30, 60, 90. And what they're trying to show you is how some of this can be developed. So if you had a square, so what they're saying is if you had a square and you cut it in half, each side would have been x, x, and x. So if I did the Pythagorean theorem, it would have been x squared plus x squared is equal to c squared. So what is my c equal? And so I would have to square root both sides. Now c would be equal to the square root of 2x squared. Well, c then is which one can I take the square root of? The x squared, and so the x comes out front and the 2 stays in. So that's where it comes from. So if you know the leg in the 45, 45, 90 triangle, you're just going to multiply by root 2 to get the hypotenuse. Something like that is true here too. I used to have an equilateral triangle, and then they cut it in half. So it used to be 2x and 2x, and then when they cut it in half, this side becomes x, or half of it, and then you would do the Pythagorean theorem again. And if you do the Pythagorean theorem, we'll just speed up the process. It just tells you it's x root 3. So let's use the stuff that we know and see if we can figure out some of these other sides. So I'll try to do it here. I'll do a couple examples. So this used to be the 30 over here. And so now I know this is the small side opposite the 30 is the small side. And if that was 8, that means it got cut in half. The big side, or the hypotenuse, would have been 16. So I'm going from here backwards. So if I go from the small side to the hypotenuse, I'm multiplying by 2. And then going this direction, you cut it in half, and now when I go that one, I say 8 root 3. Again, this one is a 30, 60, 90, so this would have been 60 here. Now I know the hypotenuse. Going to the small side, I cut it in half. That would have been 9, and then this is 9 root 3. So at any point, you might want to pause the video, try to work some of these out, and then I'll just keep going through and doing the answers. So already the 30, 60, 90, so if I go this direction again, I cut it in half, so that'll be 1, and 1 root 3 is just root 3. I went the wrong way. Sorry, this triangle is not to scale, so, or it is, it threw me off. I should have gone this way to, oh, I did the right way. Never mind. So 2, the smaller side would have been 1, and this would be 1 root 3 or just root 3. On this one, 1 to the small side would be half as much, so that now is a half, and now I take 1/2 times root 3 or just root 3 over 2. On the 45, 45, 90s, this is 45 over here. So if I know the legs, so remember, uh, if you know the legs, if you know the legs, you're going to multiply by root 2. If you know the hypotenuse and you're going backwards, you're going to divide by root 2. So I know the leg this time, so this one will also be 7, and then this would be 7 root 2. If this is 5, I would have to divide by, so I'm going to take 5 and divide by root 2, and you want to rationalize that. So I end up with 5 root 2 over 2 for one of the legs. So you divide by root 2 this time, and if that one's 5 root 2, this one will also be 5 root 2 over 2. And this one, the 45, 45, 90, if this side is 1, this side is 1. If they're 1, then you say 1 times the root 2, and that's just root 2. Same thing as here. 1 is my hypotenuse, so I take 1 and I divide by root 2, but I have to rationalize that, and I end up with root 2 over 2. So this one's root 2 over 2, and this one's root 2 over 2. So that's important to remember that when the hypotenuse is 1, we get those special things. Okay, so for this last one, we have to, we're going to do the problem, and I put the 30, 60, 90 with a hypotenuse of 1 here, and your 45, 45, 90 hypotenuse 1 there in red. So the red one is the 45, 45, 90, hypotenuse 1, purple 1. So that's how I kind of refer to them. The sign of 30, I would go to the purple triangle, and the sign of 30 would be opposite over hypotenuse. So that would be opposite 1/2 divided by 1, or simply 1/2. The cosine would be the adjacent over the hypotenuse. The adjacent over the hypotenuse is root 3 over 2 divided by 1, or just root 3 over 2. The sine of 60, opposite over hypotenuse, opposite root 3 over 2 divided by 1, or just root 3 over 2. And the cosine of 60 would be the adjacent over the hypotenuse, which is 1/2 over 1, or just 1/2. So you can see how they kind of flip-flop each other. So you can pause the video and now find the rest of these using either the kind of the red or the purple triangle. So hopefully these are the answers that you came up with. And you'll notice that the 45s are always root 2 over 2, root 2 over 2. Doesn't matter what problem you were doing it in. But this is the 2 pages in between lectures 4, 1,